AP Cactus AB, Unit 6 Day 11, warm up. Try these problems and pause the video and try them, and then unpause it and check them and see how you did. Now, by the way, just before you get started, these little numbers in here represent the area of these regions. And just emphasize you've been given the graph of F prime. Okay, so these are the areas in these regions. So that means, like on the 610 worksheet, we were kind of guessing the areas. Well, you can actually use these to help you find the absolute maximum. Bonus doesn't mean optional. Bonus just means like bonus, this one's extra hard or fun or whatever. So try the problems. Pause the video right now. Try them and unpause it. Okay, assuming that you have tried these, you've been given the graph of f prime, you have an initial value, f0 is 10, that's not on this graph, and you want to find relative maximums, electropoids increasing, concave down, f prime increasing, absolute max. So I'd label this graph first, so f prime is positive, increasing, f prime is negative, decreasing, f prime is positive, increasing, f prime is positive, increasing. This is a critical point. It's a relative. It's going up and down. That's a max, a peak. Here's a critical point. It's going down then up. That's a relative min, a valley. Here's a critical point. It is a plateau. Second derivative concavity is the slope of this graph. So here the slope of the graph is negative. So f double prime is negative. It's concave down. Here f double prime is positive. It's concave up. Here f double prime is negative. It is concave down. And here f double prime is positive. It is concave up. So you can find the inflection point. So lots of good stuff here. So relative maximum or maximums. So there's a relative maximum at x equals 1. Because you get a positive slope to a negative slope to a critical point, right? So, I mean, if you want to justify it, you can say by the first derivative test for relative extrema. And then you would want to say since f prime of x is positive on the interval 0 to 1 and f prime of x is negative on the interval 1 to 3. That's really good justification there. Anyways, inflection points at x equals 2, 4, and 5 because the concavity is changing, right? Because f double prime equals 0 or undefined, and f double prime changes signs. So increasing and concave down at the same time. So where's it increasing and concave down? Well, I'd say 0 to 1, right? And then 4 to 5, it's increasing and concave down, increasing concave down. So those two chunks. Now, should we include the endpoints or not? Well, do we include the endpoint 0 for concavity? We would include for increasing, but not concavity. It's got to be able to be included for both. 1 we would include for the endpoint of increasing, but it's in the middle of concave down, so we're good, bracket. 4, I'd include it for increasing. It's in the middle of increasing, but it's at the edge of concavity, so parenthesis. And then 5, I would include it for increasing, but again, it's at the edge of concavity, so parenthesis. So, okay. Increasing. Now, this one says f prime is increasing, which means the derivative of f prime, the second derivative, is positive, which means we're looking for concave up portions of the graph. So that would be 2 to 4, and 5 to 6. Now, we don't usually include endpoints or concavity, and we are looking for concavity, but honestly, we were asked if something was increasing. So the original wording caused us to include the endpoints. Include the endpoints because it was something increasing, even though it's connected to concavity. If I asked you where it was concave up, it'd be the same thing, but parentheses. Absolute max. So we need critical points and endpoints. So we have endpoints, 0 to 6. I'm going to plug these into the original formula, which we don't have. But like I said, it's related to the area under the derivative graph. We do know that f of 0 is 10. They just told us that. That's the initial condition. The critical points are 1, 3, and 5. So from 0 to 1, it's increasing, and the area is 4, so we're going to add 4 to this and get 14. From 1 to 3, it's going down. 1 to 3, it's going down 5. It's decreasing, so we're going to subtract 5. From 3 to 5, it's going up 4, so we're up to 13. And from 5 to 6, it's going up 4 more, so we're up to 17. So here's your max. Here's your min. So the absolute maximum, we're just really looking for the x coordinates of all these. The absolute maximum is 17 at x equals 6 by extreme value theorem. Checking endpoints and critical points. That's a good thorough answer with justification. So that's how this is usually give you those areas. So that makes it a lot easier for us to do. Again, that's not necessarily an idea that we've talked about a lot. Describe your algebra strategy for determining where f of x is increasing where. Well, I would say find critical points, and those come from f prime of x equal to 0 or undefined. And then I would do a line check, and I'd find where it was positive on the line check. Concave down, I would find where f double prime of x equals 0 undefined, and then I would do a line check, and then I would find where it is negative. Find where f has an absolute maximum. Well, identify the candidates, identify endpoints and critical points. Critical points come from f prime of x equal to 0 undefined. Make a table and plug into the original equation and find the maximum min. So that's it. Short little warm up.